Step 2 is to note the level of significance for which you are going to do the hypothesis testing. Now, the level of significance is always given to you in the problem, but what does it mean? So here's the scenario. We've got this table here. Your null hypothesis, which is what we're doing the testing on, is either true or false. We actually don't know that, but it's technically true or it's technically false. We are going to perform a test based off of some sample data that we've gathered, and we're going to ultimately decide whether we should reject the null hypothesis or if we fail to reject the null hypothesis. Fail to reject is not quite accepting the null hypothesis. It's just saying we do not have enough evidence to actually say that the null hypothesis is wrong. So again, the null hypothesis is either true or false. We do not know that. We're going to run a test and then we're going to make a judgment. We're either going to fail to reject the null hypothesis or we will be rejecting the null hypothesis. Now, let's go through each of these 4 scenarios here. Suppose the null hypothesis is actually true. We do not know that, but we run a test to decide whether we want to reject or fail to reject the null hypothesis. So if H0 is actually true and we fail to reject it, and we can almost say accept, they're not exactly the same thing. But if H0 is true and we accept H0, that means we made the right decision. Whereas if H0 is true and we rejected H0, that means we made the wrong decision. So this is an error, all right? Let's suppose that H0 is false. If H0 is false and then we fail to reject it, meaning we accept it when it's false, we've also made an error. If H0 is false and we end up rejecting it, then we made the correct decision. So ultimately, there's 4 different things that could possibly happen. In 2 of the scenarios, we made a correct decision. In 2 of them, we've made an error. Now, if H0 is true and you reject H0, that's called a type 1 error. And if H0 is false and you fail to reject it, that's called a type 2 error. Of course, we don't want to make an error at all, but there's always the possibility that we will make an error because we're using sample data to make a claim about the larger population. So probability comes into play again here. We represent the likelihood of committing a type 1 error by the Greek letter alpha. And this is the likelihood of committing such an error, so a type 1 error. It's also known as the level of significance of the test. So alpha, which is the probability of committing a type 1 error, is the level of significance of the test, which is a big part of our hypothesis testing. Before we get to that, we let the Greek letter beta represent the likelihood of committing a type 2 error. So this is the likelihood of committing a type 2 error. One minus beta is called the power of the test. This is a statistical concept that is beyond our course, so we're not even going to talk about beta or 1 minus beta. I just wanted to mention it here so that you've heard of it. The likelihood of committing a type 1 error alpha is what will matter most to us as we do our hypothesis testing. Alpha will be stated explicitly in the original problem. It's not something you come up with. Let's now move on to step 3. Step 3 requires us to determine the type of test that we're doing and the tail direction of the test. Here we're going to focus first on the tail direction of the test because this is true in general. However, the type of test depends on the scenario. The tail of the test is telling us where the rejection region is. And we'll talk more about what that means in a coming slide. For now, the alternative hypothesis is what determines the direction of the tail. So you specifically look at H sub A to determine the direction of the tail, which again is the rejection region. We'll see what that means in a coming slide. Remember, the alternative hypothesis does not have the equality in it, so it can possibly be any of these 3 things. If the alternative hypothesis is that mu is less than a number, then you're doing a left-tailed test. If mu is greater than a specific number, then you're doing a right-tailed test. And if mu is not equal to a specific number in the alternative hypothesis, then you are doing a two-tailed test. So if mu is less than, you've got a left-tailed test. If mu is greater than, you've got a right-tailed test. And if mu is not equal to, you do a two-tailed test. What tailed test are we going to do with this cell phone scenario? So remember, the null hypothesis, which happened to be the claim, was that the mean battery life was 24 hours, and the alternative hypothesis is that the mean battery life is not 24 hours. So to determine the tailed test, we look at the alternative hypothesis. And since mu is not equal to whatever that number, that doesn't matter, mu is not equal to goes with a two-tailed test. So we are going to do a two-tailed test when we go back to that cell phone battery scenario. Now, step 3 also requires us to determine the type of test, but the type of test we use is dependent on the sample that we collect. So we will develop the type of test in another video, and we will develop two specific types of tests. One is called the Z test, one is called the T test.